Hello everyone, welcome to the webinar on geometry. This webinar will discuss some topics in this unit, Unit 3. And this webinar is intended to be an exam preparation webinar. It will go over some topics, not everything that you need to know, but some topics in this unit. And today's unit is on circles. This is myself. My name is Mariam. I'm your math instructor here at Penn Foster. I am certified to teach high school mathematics in the state of Pennsylvania. I'm also excited because this year I'm gonna earn my master's degree. So hopefully everything goes as planned and I earn my master's. Today in this webinar, as I said, we're gonna prepare for Unit 3 exams, and the way we're gonna do that is we're gonna discuss the most challenging topics in this unit. This webinar is not going to cover every single topic in the unit, but it is going to cover the ones that we see that we have the most questions on, and the questions that we see most students got incorrect in the exam. So that should be helpful for you, hopefully. Within the webinar too, we're going to have self-assessment questions or self-checks. So after some discussions of certain topics, we're going to have one question for you to complete. These questions are not graded or anything. These are for you to assess yourself, see where you are on that topic. If you need help, if you need to call the school, if you need to email the instructor, if you need to do more reading and more practice on that topic. Also, questions are welcome. Your relevant questions are welcome through typing them in the questions box. The raise your hand feature is not enabled. And also all registrants for the webinar will receive the recording of this webinar. Whether you attend today or you couldn't attend and be with us today, you will receive the recording in a follow-up email. Today we'll look at the circle, just the elements of a circle. We're gonna look at the angles in circles, central and inscribed angles, and we will learn the relationship between these two types of angles. We will learn about some facts about arcs and chords in circles. We will know the difference between the arc length and the arc measure. We will look into the tangents in circles, and also we will see how we can convert an angle measure from radians to degrees and vice versa. Let's start with the common sense thing to start with on circles. What are the elements of a circle? I decided to make this part of the webinar because it is important to know the different things on circle that we will use in our formulas and our facts. So the first thing we see here is the origin. The origin is the center of the circle, and we usually label that as an O, as in the origin. And here, this line in purple is the diameter. The diameter of the circle is the segment that goes from one end of the circle to the other end going through the origin. So that would be the diameter of the circle. Half of the diameter, which is the light blue here, the line here, is the radius. If we have more than one radius, we call them radii. The radius obviously is half the diameter, as you see here. The green line that just popped up here is the chord. A chord in a circle is just a line that connects one point on the circle to another point, but that chord does not go through the origin. So that's why we call it just a chord, not a diameter or a radius. Now an arc would be that section on the circle, the outside of the circle. So this curved line from the outside of the circle that is intercepted by a chord or sometimes by an angle, we call it an arc. Sometimes we have a major arc and a minor arc. Just depends on how big the arc is and how we label the arc. Is it XY? That would be a minor arc. XYZ? That would be a major arc. Let's look at central angles in that small circle here. So the blue angle, it's a central angle, and you know why we called it that way, central angle, because the vertex of the angle is actually the origin of the circle. So this angle is a central angle in this circle. Also, another kind of angles are inscribed angles. The vertex of that angle is on the outside too of the circle. So the three vertices of the inscribed angle is on the outside of a circle. Let's see another example of an inscribed angle in brown, another inscribed angle. Now you see that sometimes central angles and inscribed angles, they subtend the same arc here, and that's what we will study further into the relationship between central and inscribed angles. I just want to remind you, if you have any questions, you can type them in the questions box. So now let's see what is the relationship between central and inscribed angle measure. As you see here, the relationship is written two different ways. It's the same way of saying the same thing, it's just different ways of saying it. So it means the same. So the central angle, the measure of the central angle, to be specific, is twice the measure of the inscribed angle. Let's see that on the figure. So EOD, by looking at the figure, we know it's a central angle. Now ECD is an inscribed angle that subtends the same arc ED. In this case, we can say that the central angle measure is twice the angle measure of ECD. Or I can say it another way. I can say, well, if the central angle is double the measure of an inscribed angle, it means that the measure of the inscribed angle is half the measure of the central angle. Think, just to remember, the central angle is bigger, is larger than the inscribed angle. The inscribed angle is smaller. If both of them subtends the same arc, this is most important. That would make this relationship exists if they subtends the same arc. Let's see an example. So we're going to look at the same figure that we have here. Measure of angle EOD. So in geometry in general, you need to look at the figure. Even in the exam, with the practice questions, anything that does with geometry, you need to consider drawing yourself a figure or use the figure that is given in the question. I say that because how would I know from the wording of the question, just only with looking at the question, measure EOD? How would I know if it's a central or inscribed angle from looking at the figure? If I do not have, or I just chose not to look at the figure, I wouldn't be able to use the fact that EOD is a central angle. So the question is asking us, find the measure of this angle, which is a central angle. Given in the question, the measure of the inscribed angle that subtends the same or intercepts the same arc. ED is the arc that both these angles intercepts. So according to the rules that we have up there, what would be the measure of angle EOD? Remember, the central angle measures more. So I can double the angle measure for the inscribed angle, 2 times 70, that will give you the measure of the central angle, 140 degrees. So this angle is 140 degrees. That's it. So all I had to use in that question is to realize the relationship between the inscribed and the central angle if they intercept the same arc. Now, what is the measure, the second line here, what's the measure of the arc? This is the symbol of the arc, the bent line here, ED. What is the measure of ED? Another rule that is important for us to know, that the measure of the arc that the central angle intercepts would be the same as the measure of the central angle, and that was written out here. So the measure of the central angle equals to the measure of the intercepted arc. So since I know that the central angle here measures 140 degrees, that tells me that the measure, not the length, the measure of the arc ED is also 140 degrees. That's it. If you have questions, you can type them in the questions box. let's look at a self-check question. This is the kind of questions I referred to at the beginning of the webinars. These, again, are not graded, and then I'm not going to have, use my time to track who did that correctly or no. These strictly for you, just to see if you are okay with this topic or no. So I would encourage everyone who's attending this webinar, and even if you are not with us today, you can pause the video whenever you have your recording and work on that question just to see where you are on that topic. So the question is asking, examine the circle below and answer the following questions. What is the measure of angle AEC? Look at the figure and we're going to figure out what kind of angle is that, AEC. So they want us to find the measure of an inscribed angle. Okay, let's look at the givens. What are the givens? Sometimes they have too many givens, but we need to use the right ones. So they have the central angle AOC measures 80 degrees, and then another inscribed angle BDC 15 degrees. How much then this inscribed angle that intercepts the arc AC will measure? For these questions, my screen will change so you're able to choose your answer from a set of given answers. So in 1 second, I'll make that appear to you and you'll be able to enter your answers. And here you go. Usually I'm going to allow like a minute or so for these questions just for you to try them, even if you didn't have if the time is not enough for you to think about the problem, do the problem, calculate, and put your answer. At least you had time to think about the problem. Okay, so I'm going to share my final answer on these questions. So since it's an inscribed angle, we know inscribed angles measures half of the central angles that intercepts the same arc. Then that would be 80 divided by 2, so that will give you the 40. 40 would be the measure of this inscribed angle. The other question says, what is the measure of the arc BC? BC in the figure is this arc. I need to find the measure of that. Well, the only given that is useful to me is the inscribed angle, but this is useful indirectly. I have to find something else before I am able to find the measure of arc BC. What do you think? What do you think here? I'm going to leave you to think about this, and here's the question. Okay, let's do that together quickly. So the measure of arc BC, remember the measure of any arc would be the same as the measure of the central angle that intercepts this arc? Well, I'm given the measure of the inscribed angle, and I know that the measure of this central angle would be twice the measure of the given inscribed angle. Then 15 times 2 will give you the measure of the central angle that will become 30, and that will be the same as the measure of the arc. So arc BC measures 30 degrees. Next, let's look at chords. As I said before, chords are just segments in the circle that does not go through the origin of the circle, and they are having some facts when they intersect, or even if they do not. But if they are equal, if CD and AB chords, as you see here in both circles, and they are also equal in length, there are some facts then results from that. So let's examine the figure on the right first. I think that's easier to imagine or to visualize than the second one. But both of them, the fact that we're going to speak about will apply to both of them, since the two chords in the same circle have the same length. So let's start with this circle then. ST and UV are chords. They have the same length. Then the result is the arcs that both chords intercepts have the same measure. Let's see that and use colors just to have more understanding of that. So this chord in this circle cuts out, if you think about it, cuts out this chord, okay? I mean this arc, and also this chord cuts out this arc. The rule says if the chords are equal, then those arcs are equal in measure. There is another set of another set of arcs that are equal in this setting. So let me erase the ones that we just did. So arc ST equals in measure to arc UV. That's obvious. What else? Okay, let's use the same colors corresponds to the chords. So if I am going to use the other arc that ST intercepts, so ST also intercepts a major arc, SUV, and this chord UV intercepts the one I'm going to mark in purple as well, and it's a major arc. So these two arcs are equal in measure as well, just to keep that in mind. So the minor arcs and the major arcs, they are equal. So let's write the results down so we have it written down for us. So for the circle on the right, we can say since the two chords are equal in length, then the measure of arc ST equals to the measure of arc VU. Also, these are the minor ones. The major arcs, S, U, T, equals to the measure of the other major arc, V, S, U. That's it. So maybe it's going to be hard for you just to study that fact in the beginning, but once you know how it works, you know which arcs have the same length. Or you can use color coding if you just starting to study that unit and you're having trouble identifying which arc is equal to which arc. In this case, you can use colors too. So let's apply the same fact on this circle. Two chords, A, B, C, D, they are equal in length, but they intersect too. The same fact apply. So let me use the colors. Let's color or mark the arc that AB intercepts from that circle. So AB will be equal in measure to arc CD here. Let's write this down. So CD, the arc CD will equal to the measure of arc AB. And also the major arcs. The major arcs A, C, B, A, C, B. These comes from the chord AB here. So let me use the same colors so everything is consistent for you when you look at the recording. So the major arc cut by the purple chord ACB is equal in measure to the major arc cut by or intercepted by. So let's write this down before we get confused here. CBD. And that's it. So let's look at a question on this topic and try to apply the fact here. In the circle shown below, if chord XY, and of course it just says in the question segment XY, but from looking in the figure, I know that XY is a chord. So chord XY equals to the chord WZ. The true statement is which one of these are true or is true? Just one statement is true. So I'm gonna leave the figure for you because when I change my screen, the figure of the circle is not gonna be there. So you can examine each of the given choices and see which one is true. Okay, let me then put the question up so you'll be able to choose the answer. Here you go. Which one is true? The two chords are equal in length. They intersect. So what is true? What is definitely true? Okay, let's then do the question together. Okay, I see that some of you have chosen that choice, saying that this angle measure here, XUZ, equals to the angle measure of XUW. And I bet that you have chosen that because the figure looks or gives us the impression that these two angles have the same measure. This is one thing, and I'm glad that you have chosen that choice. So I would bringing your attention to something is important. In geometry, we do not draw figures to scale. So you cannot assume that this angle, because it looks like the same as that angle in measure, then they are equal in measure. We cannot go by that rule. They have to specifically tell you in the figure that these two angles are equal, or in the word of the question has to say, or you have a reason, a geometric reason, not something with drawing. So this is not the right answer, and also it's not the right answer because these two angles are supplemental angles, so they would add up to 180 degrees. So that may be 80 and that may be 100. It doesn't look like it, but I mean, again, Things are not drawn to scale in any geometry course. We cannot assume that. Okay, let's go through then the one that is true. WZ equals to XY. Both of them are the arcs. So, and that is true. This arc and that arc. And that goes with the fact that we have just learned. The other ones are not true. This one is not true, this one is not true, and this one is not true. So the only one is true is this one. Whenever you get the recording, you can pause and examine why each one is not true. Any questions? Okay, let's move on to, okay, Ellie has a question. She has a question. Go ahead and type your question in the questions box. If it's relevant to whatever we are talking about, I'll be glad to answer. If it's just a general question, I'll leave it till the end of the webinar. I'm waiting for Ellie to type the question that he had. Okay, sure. So let's move on to the next topic, chords. This time it is chords again. So in this fact, the two chords are intersecting, but it's not a condition that they have to be equal in length. So in this fact, it says if any two chords, they didn't specify if they have the same length, just any two chords in the same circle intersect, then there are two things following that, intersection. One, the corresponding chord segments are proportional, meaning what? Chord segments are XU, for example, YU, ZU, and WU. We call them chord segments. They are proportional, and this formula or that expression gives or explains the proportion fact of those segments being proportional. So whenever you have two chords intersect in the same circle and you are given the length of 3 chord segments, you can use that formula to find the fourth, like in the following question. Let's read that and do it together. So if ZU, it's a segment. Look at the figure. You will realize that it's a chord segment. ZU is 3 units, 3 centimeters, 3 kilometers, 3 feet, whatever the units are. They are length units. And then XU are 4. YU is given as 10. So of course, they're going to ask us to find the length of WU, this one. Whenever you have that question within your practice questions or within your exam, you need to think which fact you can use to find the thing that you're trying to find or calculate. In this case, you're trying to calculate the length of a chord segment. So you need to think which fact would correspond to that question. Once you know which one to use, you'll be able just to, plug in the knowns and find the unknown. Let's do that. So the fact I'm going to use is the proportion on the top. So XU times UY equals to ZU times WU. Let's plug in the numbers. XU is 4 times UY is given as 10 equals to ZU is given as 3. The only unknown I have is WU. Okay, with algebra, if you have some knowledge of algebra, you know that whenever we are solving an equation with one variable, one unknown, our goal is to isolate the variable on one side and everything goes on the other side. So to do that, reverse. That variable is multiplied to 3, divide over 3. Then you're doing the reverse of operation of multiplication, which is division. So divide both over 3 to keep the equation balanced. So that will give you WU equals to, do the math here, 4 times 10 over 3 will give you 13.3 units. So that would be the length here for this segment chord segment, I'm sorry. That's it. So the point that I'm trying to make throughout this webinar, questions with circles may seem overwhelming, may seem, difficult, but really it goes down to decide which fact is this question is about, which rule. And that's it. Once you know your way, you'll be able to simply just find your answer, because those facts doesn't, require you to have good knowledge of complicated operations, just addition, multiplication, things that you can do. Just follow whatever you need to follow for that fact. Another thing that results from two chords intersecting the same circle is that each formed angle measures half the sum of the two intercepted arc measures. That's too long. Let's look at this on the figure. So each formed angle, we speak about these angles here, these angles. So this angle and this angle, that's a pair. And by the way, XUZ equals in measure to WUY, because these two angles are vertical angles from unit 1, if you remember. And also another pair that is equal in measure is XUW and ZUY. So each pair of these angles will equal half of the sum of the two intercepted arcs. Okay, which arcs they are referring to? For these angles, I'm gonna mark them in purple. I'm looking at this arc, the arc measure WY, and also the arc measure XZ, because these two arcs are the arcs that these two angles intercept. If you add the measure of arc WY plus the arc measure of XZ, take the half of that, that will give you the angle measure of this angle, which is also equal to the angle measure of this angle. Same thing with the other pair. So this pair here, I'm looking at this arc and this arc. Add the two arc measures, take the half, that will give you the angle measure, this one and this one. Let's do an example. So FXZ, that's the arc, let's look at XZ. They're referring to this arc measure. It is 15 degrees, that's given. And the arc measure of WY is 45 degrees. Find the angle measure of XUZ, which is one here, XUZ. How? Whenever you see that question, you're given two arc measures. They happen to be the arcs that both vertical angles intercept. Then right away, you're going to think about this fact to use. So let's use the rule. Measure of angle XUZ, that's an X, not an H, XUZ equals to half the measure, half the sum of the measure of XZ plus WY. I'm rewriting the facts because it is a good habit to rewrite the formulas or the facts that you are using. So as you write, your brain is understanding more about the question. And also, whenever you are replacing variables with numbers, you're not mixed up. You're not recalling things from your mind and then you mix up and then you end up with the incorrect answer. So equals to half times XZ was given as 15. So put 15 plus WY is 45. Now, we're not going to do half times 15 and then plus 45. We're going to give the priority to whatever is inside the parentheses, 15 plus 45, and then take the half of the sum. So the sum is 60. take the half of the 60, that will give you 30 degrees. So this angle here is 30 degrees, and this angle here is 30 degrees. That's it. Any questions? Okay, let's look at a self-check on this topic. In the circle below, if the arc measure AD, so it is another good habit to whatever is given as words in the question, you put it on the figure. So the arc measure AD is given at 60, as 60, so 60 would be here. And then the arc measure CB, which is this one, 40 degrees. They are asking us to find the measure of AED. AED, this one. Easy, right? Now you know why we're going to choose the fact in the previous slide. We're asking about that angle measure, and it happens that the two given arc measures are the ones intercepted by the vertical pair here. So I'm going to leave you to apply the rule. Half of the sum of the arc measures. So here you go. Okay, let me share my answer. So how do we find the angle measure AED? Half the sum of the intercepted arcs. So that would be half times 60 plus 40, which is half of the 100, which is 50 degrees. So this angle is 50 degrees, and of course that makes this angle also 50 degrees. Now the second one, just want to give you a heads up, this question is not from this unit. So that's another thing to consider with doing exams. Whenever you are working on exam for unit 3, keep your mind open for other facts that you may have to use from other units, like this question. What is the angle measure of AEC? This one here. What do you think? How do I find that? That's from another unit. Just want to show you how a question can relate to two different units. So you need to, consider every option that you can use to find the question. So I'm gonna put the question up and try to think about how you're gonna get the angle measure AEC. Okay, let me share my answer for this question. And I see that I think one of you had the right answer. And by the way, if you did get the incorrect answer, it does not mean that you're gonna do bad in the exam. It's just a sign for you that you need to go back and study, but it does not mean that you will never get geometry. It means that we just need to work harder and to put more time and maybe use the resources available for that course. So this angle is a supplementary angle to this angle. And you know, supplementary pair, they sum up to 180 degrees. Then 180 minus part of it is 50. Then when you subtract that, that will give you 130. And this is 130. If you want to check your work, 130 plus 50 will give you 180 degrees. This angle is 180 degrees. That's correct because this line is a straight line. So that makes this angle a straight angle, which we know measures 180 degrees. Any questions? Okay, let's move on to another topic. Arc measure and arc length. What is the difference? How can we understand the difference between these two topics? Raise your hand feature is not enabled if you have just joined us later. If you have a question, you need to type the question in the questions box, and then we'll be able to see who asked the question and what exactly the question is. So arc measure and arc length. Let's think about the difference first and then see how we can do some calculations with that. The arc measure is just a measure of the central angle that intercepts the arc. We know that. We know that by now. So it means that I am looking for how many degrees the central angle extends over the arc. How many degrees the central angle extends over the arc, this arc. And that's why we said if the central angle measures, for example, 50 degrees, that will make the arc measure as well 50 degrees. Now with arc length, it's, you know, as it says, length. It is as if you have a measuring tape and you are extending that measuring tape over this arc and you want to know how many inches, for example, is the arc, or how many meters the arc is. How would we, if given the length, for example, how would we find the measure? Or if we are given the measure, how would you find the length? Let's figure out this in the next slide. So whenever we are given either the length and then find the measure of the arc or the other way around, we need to use a proportion. So a proportion is two equal fractions that we know they are equal. So we're using that with some factual information. So see, these two fractions have factual information, facts about circles. This and this are factual informations. Why? One complete circle we know is 360 degrees. This is a fact. No matter how big or small the circle is, the full circle is 360 degrees. This is in terms of angle measure. In terms of length, a full circle is actually the circumference of the circle. And we know, I think from Unit 2, if I'm not mistaken, or maybe from another course in math, if you have taken that, the circumference of any circle equals to 2 times pi times the radius of the circle. So these two figures here, these two values are facts about the circle. The top ones would be the knowns and the unknowns. Sometimes we'll be given the measure of the arc, find the length, or you have the length, find the measure of the arc. Let's do an example just to make everything clear. What is the length of the arc? See the bent line, the arc CD. So we're talking about the arc CD. I'm looking for the length. So let's see what else given. In this circle, I have the radius given. That will help me get the circumference. So the circumference is known because I know the radius. 360 is just a number I'm going to use as is. The measure of the arc. Do we know the measure of the arc? Well, they gave us the central angle measure, which is the same as the measure of the intercepted arc. So actually the measure of the arc is also 35 degrees. So by now I know I have 4 values, 3 known and 1 unknown. Let's write this down and see how we're gonna solve the proportion. The length of the arc is not known. Length of CD, this is what we're trying to find. The circumference of the circle, let's do that on the side. C equals 2 times 3.14, which is the value of pi, times the radius is 3, equals 2. You're going to do your math and you'll find out that the circumference is 18.84 inches. So that goes here. So length and length. This fraction has the lengths. So circumference is a length, and then the length of the arc is a length. So put that figure here. The second fraction will have the degrees, the angle measures. We know that the first circle is 360. What about the measure of the arc? It's given indirectly in the question. It is 35 degrees. Now, to solve a proportion, this is my way, and I find it easy, but you can find or you can use your way if it gets you to the right answer. The way I do that, cross multiply the known values, divide over the remaining value. So multiply and then divide. That will give you this value. So let's write this down. Length of CD equals 2, multiply 35 times 18.84 divided by the remaining value, 360. So multiply first and then divide. That will give you the length of the arc CD, which is going to be 1.83 inches. That's it. Again, the question may look overwhelming. How come I'm going to come up with the length of an arc and only they give us a radius and a central angle measure? Again, you need to think which fact we're going to use, which rule, which proportion, and you can go from there. Any questions? Anything wasn't clear, or you expected me to say something on that topic and I didn't say it? Okay, let's look at the self-check question on this topic. What is the length of the arc EB? Let's mark this on the figure. So EB is the one I'm trying to find the length for. If the circumference of the circle is 100 feet, so they gave us in the question directly the circumference of the circle. They give us too the measure of the central angle that intercepts the arc. Before I put the question up, I'm gonna rewrite the proportion for you. So, because I'm sure you didn't memorize that, so 360 degrees. Here would be the measure of the arc, EB. You need to figure this out from the question. The length is the unknown, length of EB. And then here goes the circumference. Circumference is what? And you can go from there. So I'm gonna give you some time to figure out the answer. Here you go. Okay, let's do that question quickly together. So as we said, let's erase the some of the values and put the numbers instead of them. The circumference was given. Also, the measure of the arc is indirectly given in the question. So, and instead of these, we're going to have the values. The circumference is given as 100 feet, and also the measure of the central angle is the same as the measure of the arc, then that would be 50. Multiply and divide, and that will give you the length of EB, which is going to be 13.89 feet. That's it. Okay, let's see another topic, tangents. So tangents with circles are just lines that intersect the circle at one point that we call the point of tangency. So, example, on that figure, AC is a tangent to circle O because AC intersects circle O at A, the point of tangency. Same thing, BC is also a tangent and the point of tangency is B. Okay, what happens if two tangents like these intersect outside the circle? See, the angle of intersection of these two tangents is angle C. What happens? One, AC and BC are equal in length. They become equal in length. So that's one. Two, the measure of the outside angle where the two tangents meet would be half of the difference of the minor and the major arc. And then the third fact is the radius is perpendicular to the tangents. Whether they intersect actually or no, the radii would be making a 90 degrees angle with the tangents. So these are the three facts we need to keep in mind whenever we hear anything about tangents or see tangents in our figure. These are the three things that may be helpful for us to answer the question. So let's look at an example and see how would we apply these facts. What is the angle measure of C? And you see that is the outside angle with the two tangents, and I know they are tangents because they are only meet the circle at one point. AC and BC are tangents. We're looking for the angle measure of C, and then they give us something else. They said that the major arc, which they mean this is the major arc, 210. How do I know the angle measure of C? Let's remind ourselves of the fact. We know that the measure of angle C equals to half the difference of the major and the minor arc measure. So that would be AEB minus the measure of the minor one, AB. Let's look at this in the figure. That's AB. So AB, that's a minor, and then the major is this one. I know the major. It's given in the question. So put 210 in place of that. I still have the half outside. Minus, what is the measure of the minor one, AB? What do you think? Something factual about the circle. A complete circle is 360, right? Now, if I have part of it is 210, then what would be the angle, the arc measure or the minor arc measure? Just do the subtraction. That will give you 150. So that tells me that this part is 150. So I'm going to use that in my formula. Subtract first and then take the half of the difference, and that will give you 30 degrees. That would be the angle measure of the outside angle C, 30. Any question on that part? Anything that isn't clear? Okay, let's look at the second question. What is the measure of AOB? AOB, it's a central angle What do you think? Easy, straightforward. Well, since the arc measure that this central angle intercepts is 150, then the central angle measure itself is what? 150 equals to 150. That's it. It's that easy. Some questions I see in the exam that they're straightforward, just depends on your knowledge of what's in the unit, what is the facts, what are the things that were discussed in the unit. So you need to pick the one that is correct or the right one to help you with the question. Okay, let's look at a self-check question. Tangents, right away, just knew from the figure tangents. Then I need to remind myself of the 3 facts I know. Examine circle O, then answer the following questions. What is the measure of AEB? AEB is the major arc. What do you think? Something given in my figure, the central angle measure is 70. That makes what 70 as well? I'm going to let you answer that in here. Okay, let me answer that question. Well, it is obvious that the angle, that the arc measure AB is also 70 degrees. And I know that the full circle, the full circle arc measure, if I would say that the circumference figure, the circumference measure would be 360 degrees minus 70. That will give you the measure of the remainder or the major arc we're looking for. So that will give you 220 and 90, I'm sorry, 290. It's close to lunchtime, I know. Okay, number 2. What is the angle measure of ACB? Okay, ACB is the outside angle where the 2 tangents are intersecting. Remember the rule? Half of what? Now you know the major arc is 290 from the previous part, and then the minor one is 70. What you need to do with them? I'm going to let you do that yourself. Don't forget to take the half of the difference. Half of the difference, right? Remember? Okay, let me share my answer. You're going to take half of the difference. So you're going to do 290 minus 70. Take the half of that. That will give you 110 degrees. So this is 110 degrees. And then number 3, what is the measure of OBC? Tangents and radius. Tangent and radius. What do you think? Just a straightforward fact that we learned. Here you go. Okay, I'm running out of time here, so I need to keep on time, which is like literally 1 minute I have left. So it's 90 degrees. So the radius makes a 90-degree angle with the tangent. Last topic I'm going to discuss with you is how would you change degrees to radians and vice versa. One fact that we need to know is how many degrees in 1 radian. So a radian is bigger than a degree. So degree is tiny, and the radian, 1 radian is big. So 1 radian equivalent to 57.3 degrees. We're going to use this fact along with this proportion to switch between degrees and radians. Let's do the question. What is the measure of angle A in radians if it measures 105 degrees? What do you think? We're going to use that proportion. So the proportion again calls for factual information. 57.3 degrees equivalent to 1 radian. And the tops are the knowns and the unknowns. The known is the degrees. So this is known and this is the unknown here. So let's use the numbers instead of the labels here. So 57.3, that's a fact. 1 radian, another fact. They are equal. The given is 105 degrees, goes on the top where the fraction has the degrees as well. And then that will give us the measure of angle A in radians. Same thing that we did to solve the other proportion. Cross multiply and then divide. Multiply, divide. So measure of angle A equals to 105 times 1 divided by 57.3, and that will give you what? 1.8. What's the unit? Radians. And same thing if you are switching back to degrees. Let's do the example. The same exact proportion, by the way, nothing changed. The only thing you're going to change is instead of having radians unknowns, this time you're going to have the degrees unknown. So 57.3 equivalent to 1 radians. And the given this time is 4 radians. 4 radians is how many degrees? Measure of angle A in degrees. Multiply, divide. Measure of angle A in degrees equals to 4 times 57.3 divided by 1. That will give you the measure in degrees, 229.3 degrees. That's it. 0.2 to be specific here. Self-check for you just to see, even if you have the full time to go about, usually, I like to end the webinars on time, so I'm going to keep down the screen, take about a minute or something to think about it, and I will populate that question to pop up on your screen. And what is the measure of ACB, which is an inscribed angle, in radians if AB, the arc, measures 65 degrees? So 65 degrees is the arc measure, which is equivalent to the central angle measure, right? So the central angle measure is 65. The inscribed angle intercepts the same arc, AB. What would be the angle measure in radians if you know that the inscribed angle is how many degrees? Can you figure this out? It's 2 steps here. 2 steps. Let me share my answer. So first, and I think I didn't put the figure long enough, so let's do that quickly. 65 degrees is the arc measure. This central angle would be 65 degrees. The inscribed angle will be half of that, 32.5 degrees. So we're going to use the proportion equals to 75.3, 1 radian. You know the degrees, so that will go here on the top, and that will be the unknown. Do the proportion, and your answer would be that a measure of angle ACB would be 0.567. That's it. Radians, of course, and that's a 0. And that's it. So it's not that hard. Even the other facts in the unit that I didn't go through in the webinar, it's not that, complicated, just a fact of learning them and recognizing which fact you can use in which question. That's it. That's it for the webinar. We went through the elements of a circle. We looked at the relationship between inscribed and central angles. We looked at tangents. We looked at chords when they intersect, if they have same length or no. We also looked at the length and measure of an arc, and we learned the difference. And we also converted between degrees and radians and vice versa. For the exam, please prepare well for the exam. Use your guide, the study unit. Use the answer key provided to you, and this answer key will cover the practice exercises within each unit, so you can check your answer and see if you are on the right track. This is a good way to study. Also, the resources for the course, you can call the school, you can email the instructor through the help center, you can attend the office hours, which is usually Wednesdays. You can just use that link. No registration required, 2 to 3 Eastern Time. KhanAcademy.org free. They have good recorded lectures, and also YouTube. You can search by topic and learn more about whatever you're not sure about. And that's it. Thank you so much for attending. Thanks for your participation in SelfCheck Question, and I hope that webinar is helpful resource for you to prepare for the exam. If you have no questions for me, I'm gonna end the webinar. I'm just gonna wait for 20 seconds or so. If you have a question, you can type it in. Hopefully I can answer. Okay, then I will wish you good luck in the exam. And as I said, after the webinar, still, if you have questions, you can email your questions or call. Thank you.